So now that we've talked about the structure and functionality and motivated the need for this pattern, let's go ahead and take a look at the implementation of the prototype pattern in C++. What we're going to do here is we're going to use this pattern to connect the iterator interface, which is the bridge's abstraction role. This is expression tree iterator and its methods, with the implementation hierarchy, which is done using the prototype pattern. And at first you might think, oh, this is just good old bridge. Well, it's kind of good old bridge, but it's not quite good old bridge because it adds this concept of creational pattern, which is not what a bridge is. A bridge is a structural pattern. And what we're doing here is we're creating the appropriate instance by cloning. So if you take a look at the code here, you can see that we've got the expression tree iterator operator plus with the post increment syntax, which is that weird within the open and closed parens. And what we're saying there is we're saying, hey, in order to implement this semantic of post increment semantics for an iterator, you need to clone the current implementation, which again could be pre-order iterator impl, post-order iterator impl, in-order iterator impl, and so on. Go ahead and clone that guy, make a copy of that, of course, stash that away in a local variable, then go ahead and increment using, in this case, the pre-order increment operation, or not the pre-order, the pre-increment operation, and then return the copy of the one that we had done by cloning. And this allows us to get this copy without breaking the encapsulation at all. Here's what the clone method could look like. This is just showing the pre-order iterator impl clone. We'll look at the other ones here shortly. This is going to encapsulate the details of making this copy. And you can see here we just use the copy constructor internally, but the fact that we're using the copy constructor is not exposed to the abstraction role in the bridge pattern. All we see there is just the call to clone. So it's nicely decoupled and good separation of concerns and so on. So now that we've walked through the implementation at a high level, let's go ahead and actually explore the code in a bit more detail. So here's the expression tree iterator, and this plays the role of the abstraction class in the bridge pattern. And you can see that it's got kind of the full complement of iterator operations for a forward iterator. So it's got the dereference operation, it's got a const, a non-const version, it's got the operator plus, which is the pre-increment version, it's got operator plus, which is the post-increment version, which is what we're going to focus on. It's got some delegation operations, it's got equality and inequality, and so on and so forth. And under the hood, it's got a ref count to the iterator impl, which we're going to look at in just a second. So if you go look at the iterator implementation, this is where things get interesting. You can see that most of the operations just forward to the underlying operation defined on the iterator impl, which we'll look at in just a second. So here's operator dereference, non-const version. Here's operator dereference const version. They both look pretty much the same. Here's the pre-increment version of operator plus. You can see it just goes ahead and calls the pre-increment operation on the implementation of the iterator. And here's the delegation operator, same as always. Now things get interesting. So at this point, we use the magic of the clone method on the iterator impl in order to make a copy of the concrete type that iterator impl is actually the base class of. And we'll look at that in more detail in just a second when we take a look at the iterator impl hierarchy. So in this case, we get a copy, we increment with the pre-increment operation because that just needs to increment the iterator by 1, and then we return the copy before it had been incremented. And then operator equality and operator inequality are very straightforward. So let's now go take a look at the iterator impl hierarchy, and you can see that this is a bit simpler. It doesn't need all the methods that the expression tree iterator's abstraction class had. It just needs to have the ones that are used to implement the semantics of forward iterators. So you can see here it's got const and non-const pure virtual methods. It's got dereference operations. It's got the delegation operator. It's got pre-increment plus, and it only needs pre-increment plus. It turns out we don't need to distinguish those things. That's handled by the clone mechanism in the bridge patterns abstraction role in the expression tree iterator implementation. So here, this is what differentiates those things by the implementation done in these methods, not what's actually defined down here. We can share that implementation. Here's the clone method. This, of course, is what's needed to implement the post-increment semantics. And then we keep track of the expression tree, and we've got some other stuff that we've talked about when we discussed the iterator pattern and the strategy pattern before. Right now, I'm just focusing on the clone mechanism, so everything else is not important for this discussion. If you take a look at the different subclasses of iterator impl, you'll see that they override all the methods, and they also override the clone method. So we have clone for in-order iterator impl, and here's pre-order iterator impl, and that, of course, has its own clone method and so on. So take it on faith that every one of these concrete derived classes has a clone method. And if we look at the implementation of this clone method, that's where things get interesting. And so if you take a look down here, you can see that here's the clone method for in-order iterator impl, and that's simply going to go ahead and make a new in-order iterator impl copy by using the copy constructor. So that's the clone mechanism for there. Here's the one for pre-order iterator impl, same exact thing, just changing the name of the class. Here's the post-order iterator impl, same thing, just changing the name of the type that's created. I think you get the point. They're all identical. And that is so often the case with patterns. It's, as I like to say, it becomes paint by number, because it's pretty much just doing it by looking at the pattern, knowing it's a match for the problem, for the context you're trying to address, and then going ahead and applying the descriptions that are captured in the structure and participants portion of the Gang of Four book chapters. Okay, so that's basically implementation. I hope that makes it more clear. It's really not that complicated, but it does help to clean the code up quite a bit, because when we write this code up here for post-increment operation, it's just really simple, and the concrete details of the subclasses never bleed into the actual interface that's used by the abstraction role in the bridge pattern that we're using to implement the expression tree iterator.